In this video, we're going to talk about databases in Azure, specifically Microsoft SQL databases in Azure, what they are, how they work, and more importantly, why you want to use them as opposed to something in your own personal environment. Now, before we get too in-depth into the Azure database, I'm going to start off by showing you how you might configure a SQL database in-house and ultimately why you don't ever want to do that. So we'll start off here with an initial setup. Your boss has come to you and your boss has given you this server right here. They have gone ahead and said, go ahead and take this server and install SQL on it. They may or may not have given you very much details as far as performance requirements or needs or capacity or anything else along those lines. But we'll go ahead and start it off here. And you've already listened to me. You've listened to me in the past and you've seen, hey, you know what? I should separate my OS disk from my SQL disk. They're two different roles. If my OS drive dies for some reason, I want my SQL to be still working. I want to just simply be able to replace my C drive and continue on with my SQL. So you've gone ahead, you've split those out into two different disks. In fact, you've set them out into two different sets of disks. These are both mirrors or RAID 1s, so that if one of these disks dies, such as that guy, the operating system is still working. And if one of the SQL drives dies, such as that guy, the SQL configuration keeps working as well. So you've gone ahead, you've started off a pretty good environment. Your boss may or may not be very happy with the fact that you now have 4 hard drives, 4 SSDs possibly in your environment, but he or she is very happy that the system is up and running and is working fairly well. Now, a little bit later on, you start realizing that your database needs some additional capacity, maybe some additional performance, and maybe additional redundancy. And so what you do is you add a separate database drive. So you still have your OS drive, say this is your C drive, and you have your SQL install, maybe this is your D drive. And what you did is you went ahead and you created a separate set of disks specifically to host the databases for your SQL. So maybe this is the E drive. Now, because database is the most important portion here, instead of just simply doing a mirror, you do a RAID 10. That gives you the reliability, so that if a single disk fails, you are still working, as well as it gives you performance, the added performance that might be necessary for your database. So your boss still isn't happy now that you're not just doing 4 disks, but you're now doing 8 HDs, hard drives. But at least you have a good plan here. Your OS and your SQL installs are completely separate. So if your OS drive dies or your OS gets corrupted, your data is still working. If your SQL install gets corrupted somehow, your database is still secure. In fact, you can even start doing things such as installing updates or patches to your applications and to your OS. And because these are happening on separate disks, your database isn't negatively impacted. The OS and the SQL install disks can be doing their own thing while the database is still running perfectly fine on its own RAID 10. There's no performance impact to them. All right, well, you've been going along, you've been looking at this system, and you've noticed that this database drive is getting a high utilization. In fact, so much so that you're starting to wonder what you should do. Should I add new disks? How could I possibly break this out? And you realize that along with the database drives, you also have logs. So what you do is you add yet another set of disks here specifically for your SQL logs. And what this means is that any reads that come will go against your database. And then any writes will end up hitting your log drive, and therefore you're able to separate out the majority of your reads versus writes. Now, that's not 100% of reads versus writes there, but that is generally the way how a lot of it works. Writes go into the logs. After a while, the logs get merged into the database. So therefore, you're separating out your reads versus your writes, and you're able to improve almost double your performance based on having a separate set of drives, specifically in that case. So you're running along and you're still looking at your system, and your database and log drives are still high utilization. So you're looking at the system and you're trying to figure out, how else can I improve this? Can I add more drives? And yes, I can. I can add more drives. I can keep scaling these out and add go from 4 to 8 to 16. I can put tons and tons of drives on this, but after a while, I'm going to start getting a diminishing returns. So I'm going to start looking at that database and log file or log drives and start looking to see what other roles there are. And I can start adding in the temp DB, and this is the transaction logs. Transaction logs is kind of like a scratch pad. While the database is doing something, it needs a temporary location in order to store information so it can sort it and organize it and filter it. And so that's what the temp DB is for. Depending on the database configuration, this can actually happen quite a bit. So by separating out your temp DB, it improves your performance considerably. Now you'll notice here that this is a RAID 0. There is no redundancy in this configuration, which most of the time is perfectly fine. The temp DB is just that, it is temporary. It's transactional. When the machine goes offline, everything in here gets deleted anyway, so it's not necessarily important for it to be recoverable. The RAID 0, however, is there simply for performance. Alright, so you're running along and you're still looking at your system and things are still running slow. You're looking at your database, you're looking at your logs, you're looking at your temp DB, and you realize that you are using a lot of your indexes. So you come back again and you add in more drives, this time for your indexes. Again, another RAID 10 for all of your indexes, so that when I'm searching for things through the database or adding things into the log files, those will query and add into the indexes so that the searches and updates work faster and my database runs even better. Whew. Alright, so we started off for this system with just 4 drives, and now we have 4, 8, 12, 14, 20 disks here. Oh my goodness, this is getting crazy. This is no longer just simply a box sitting in the corner. This is now a box with a small SAN attached to it. And when I'm saying add extra drives, these are all independent hard disks. You do not want to have both of these roles running at the same time on the same drive. Alright, so at this point, things are starting to work pretty good. Your performance may or may not be okay. However, you've realized that you missed one very, very important goal. In fact, it's so important, this is what could be considered a resume generating event. And that is that you forgot your backups. Whew. So with all of this, you then come in and you throw in some more hard drives and you say, I need some place to store all my backups. So that when my database and my logs and my temp DB and my indexes, when they all run, I can back them up straight into my backup drives that are on my local machine. In this case, performance isn't necessarily as big of an issue as with the other drives, so you can go with a RAID 5. Your primary concern with backups oftentimes is capacity. Performance can be an issue if your backup window is really, really small. However, most cases, a RAID 5 is sufficient. Great! So you have now built out your entire environment. You've separated out all your roles as much as you possibly think you can, but it still can get bigger. Here's the interesting thing. This database drive that you have right here, right now this hosts all of your databases. All of the tables for your database are right there on that one set of drives. You can actually break it out. You can have different databases on different database drives. You can have different tables inside your database on different database drives. Same thing with your logs and with your indexes. You could put all of these on different sets of drives, and so you could further scale it out to where you have multiple RAID arrays for your databases, and multiple RAID arrays for your logs, multiple RAID arrays for your indexes. Oh my. We've now gone from just simply 4 disks to hundreds of hard drives. And here's the interesting thing, here's where the problem really comes out. If I started off with just simply this one server with 4 HDs, scaling from that to that is nearly impossible. Pretty much you're talking about going back to your boss 5, 6, 7 times, asking for more and more money every single time, and your boss is not going to be happy with you when you keep coming back to the well saying, I thought I had it figured out, but I need more. I mean, even if your boss simply forgot to tell you exactly how much capacity and how much performance you needed, coming back over and over, they're not going to be very happy having to spend more and more money every couple of weeks when you come back saying you need more performance. So, as you can see, this starts to become a management nightmare of trying to configure SQL in a production environment. Even though it started off in a small production environment, it quickly grew to a very large production environment. And even if you'd started off from day one saying, oh, I need all of this, I need not just these different drives, but I need 5 sets of DB drives, I need 3 sets of log drives, and I need 2 sets of indexes. Even at that point, your boss still is not going to be very happy having to spend that much money on the offset or on the outset. So that then takes us back to Azure SQL. First off, did you know all this? Did you know that you could do all this with SQL? Unless you're a seasoned SQL engineer or have been working with SQL for quite a while, this may be all new to you. I can separate indexes from my logs. There's a difference between indexes and logs. Yeah, that may be all new to you. So you may not even know that that's possible. And then secondly, how much do you scale this out? How many sets of disks do I need for my database? How big should that RAID 10 be? Is RAID 10 really the right answer for my database, or can I get away with a RAID 5? Who knows? So you can come up with a whole lot of planning and whatnot in order to come up with this, or you can go back to Azure SQL databases. And an Azure SQL database is a database as a service. Imagine that, database as a service, right there. This is very similar to what we were doing before when you looked at the web servers in Azure. You don't get a physical server. You don't get even a virtual server. What you get is platform as a service. You get a database. You don't have to worry about the underlying infrastructure. We never even talked about what kind of motherboard, what type of CPU, how much RAM, or anything else that would have been in the physical server. You simply say, I need a server. And let me tell you, it is so easy to be able to set up. Let's actually see if we could do it right now. Here I am in Microsoft Azure. Confirm up at the very top there that this is in fact running a Microsoft Learn sandbox, so I'm not actually going to pay for this, which is always a bonus, especially since I'm going to delete this as soon as I'm done. So I'm going to start off over here, create a resource. And what I'm going to do is I could choose SQL database here, or I could choose databases on the left-hand side, and then choose which type of database. Just to be careful, I'm going to go back to getting started and just choose the plain old SQL database. Here I go ahead and I set up my resource group and my subscription. I give a database name. As always, try to stay with some sort of an initial and then a database. Oh, I'm sorry, this is a database. The database name probably is going to be dependent on your application. So let's say my application is Widget Creator. So I'll create a database called widget creator. Hopefully that's how you spell widget. The server name, go ahead and create new. It will ask us for a name. It has to be a wholly unique name. So ECG SQL 001. That should work. Server admin login. Do not use SA. Do not use administrator. I'll do test admin. And then my super secret password. Oh. Password 0123. There we go. Let's see, I don't want Asia. I don't know why it started in Asia. Let's try US West. Yay. Do I want a SQL Elastic Pool? We'll talk about this in a little bit. What size of a database do I want? Let me actually look at my notes to see exactly what size of a database I want. That's interesting. I'm following along with the lab notes, and it says choose the one that you need. That's interesting. All right. Well, we'll see which one we need. So there are general purpose databases, and see provision. That means that it is actually going to be my server as opposed to serverless. Compute core, compute generation, Gen 4, Gen 5. There we go. vCores. How many virtual cores do I need? Start off with 2. You go all the way up to 80 virtual cores. Oh my goodness. I'll go back. As we change the virtual cores, you'll also see that the data size max changes. Here it's 1 terabyte. If I keep scrolling all the way up, I can go all up to 4 terabytes. Because this is a sample environment, I'll stay low. For the database size, I'm going to say my database is only 32 gigs in size, simply because this is a test environment and I don't need anything more. Let's see, is that it? Yes. I could choose basic. Oh, I see. Choose basic, standard, or premium. That's what it was telling me there. Okay. So I could go even smaller. I could choose a basic database, 2 gigs in size. I can do a standard database, or a premium for IO intensive. Because this is a test lab, I'm going to do basic, and I'm just going to go as that. The DTU here, there is a nice little pop out, specifies what DTU, database transaction units, database something unit. Yeah, go ahead and read that. It tells you all about what that means. I'll say okay, and then I'm just gonna say, let's see, networking, connectivity, public, private, additional, use existing data. No, I could restore from backup, or I could use a sample AdventureWorks database. Collation, this is the standard collation. Unless you need it to change it, leave it as is. Tags, and then create. All right, so while that's going, let's go ahead and talk a little bit more about SQL. So the administration for SQL pretty much near zero. When we were talking about building out our own machine, we had to identify which drives go where, which database, which sizes go on which, or how many disks are used for each type of drive and which data goes on it. Along with that, we also have to configure, tons of stuff. What our backup policies are, how we back it up, when we back it up, how we do our indexing, how we do antivirus, how we do blah blah blah, every single thing about that server, how the server is physically powered, is it on a UPS or not. We don't have to worry about that. In Azure, pretty much we manage our logins, who has access to it. We can tune our indexes, although there is some tuning automatic in there, as well as optimization for the queries. Now, that's pretty much what we don't have to do. The cool thing is a lot of everything in Azure is exactly the same as standard installed local SQL, such as the tools. A lot of SQL database administrators use Microsoft SQL SMS Management Studio. Microsoft SQL Management Studio. There we go. What this is just a standard management tool that runs on your desktop, connects up to a remote server. A lot of SQL administrators live in it and literally do not want to use anything else. The cool thing is that Microsoft SMS can work on Azure SQL. You use the same tool, you just point it to a different server. It works exactly the same. Programming languages. I like to do everything in Perl. I like to do everything in Python. I created a C program that connects to our SQL server. It works just perfectly fine with Azure SQL as well. And additional frameworks that allow you to automate your SQL configurations. Those all work exactly the same with a local SQL environment as well as a remote SQL environment. Here's where the really awesome part comes in that we never even touched in, which is business continuity. When you set up a SQL server in Azure, you get 3 database nodes. When we were talking about scoping out our one server, we got up to hundreds of hard drives with a server, but that was only one server, and the old saying, one is none. So here we get 3 nodes, 1 primary, 2 secondaries. If the primary goes down, we've still got 2 fully running environments. One of those will become the primary, and we can immediately start working in it. Along with that, we have a point-in-time restore capability. Basically, every 15 minutes, it takes a snapshot of our environment, and we can restore to that point. If we're in a standard database, we can do that for up to 7 days. Basic, up to 7 days. Standard, 15 days, and premium up to 35 days of 15-minute increment recovery points. Let's actually look at that really quick. Point-in-time restore. If our database is finished, yay. Here is my widget creator database. Right here is our restore button. So I can go ahead and click restore, point in time restore, and we can actually choose a restore point. This has not been running long enough. No restore point available. There you go. It has not been running long enough for it to have a restore point. But basically you would just click this little button right here. You would choose a day, you would choose a time, and then you would choose which server to restore to, whether you want it to restore to the same server or a new one, and then say OK. And it's literally that simple. It takes a few minutes for the restore to occur. For a simple database, it may take up to 20 minutes. I've seen it. However, it's automatic. It automatically backs it up. It automatically restores the databases without any major issues. Let's see. So database restore, database copies. Ooh, yes, we can copy our database. If we come back here to widget creator, yes, discard that. There's a nice little copy button here. Maybe our widget creator database is our production database, and our developers are asking for a copy so that they can make changes to it. Well, that's not a problem. We just simply click copy. What do we want to call it? Widget creator copy, widget creator dev, dev widget creator, whatever we want. Specify the server for it to go to. We can send it to our same server or a different one. And then OK. It's now making a copy. This database, in fact, is empty, so the copy is not going to really take that long. But it's now making a copy of that database that I can then grant to our developers. Along with that, I can export and import. So I can go ahead and export this database to a storage device, storage account in Azure. Once it's exported to the storage account, I can then download it locally. Same thing, I can go ahead and upload something to a storage account and then import it into a database. So if I want to get the data out of Azure or into Azure, that is exactly how I would do it. It's a piece of cake. It's literally just an export and import. All right, so not only can we get a local restore, but we can also get geographic replication. So we can do geo replication so that if not just if our database dies, but if the entire geographic region dies for some reason, we can go ahead and recover to a remote location. So if we go back to our database here, right there, geo replication on the left-hand side. Let's see, this guy is currently in West US. There we go, West US. And it's trying to, oh, that's the second database. Maybe I don't want West US, I want it to go to East US, so I can specify for it to go to a separate database on the East US. It will replicate all the data from West US to East US once the server's done building out. There you go. Create geo-replicated secondaries to protect against prolonged data center outages. Secondaries do have price implications. I am running a second database server. I am replicating all the data there. There is going to be some cost associated with it. But that could be pretty minimal. For instance, my primary server, primary, can be top of the line. Top of the line. It could be, 5 terabytes in size. It could be tons of hard drive, tons of CPU, tons of RAM. But then my secondary can just be simply a or a warm standby. Not quite as much CPU, not quite as much RAM, just simply enough in order to have the system running, and then it just simply replicates from primary to secondary. If the secondary is ever needed, bring it online. Up it to a higher CPU system, and we're golden. Alright, SQL Performance. Well, the performance is pretty much awesome and automatic. Let's see, we can go ahead and look over here on the left-hand side. There is a performance overview. Now, this server was just created seconds ago, so it's not really going to have a whole lot of performance information. But it will tell me about my SQL transactions, how much CPU, how much RAM I'm using, what my high utilization processes are. Along with that, it will then give me recommendations, and it will say, hey, this database needs a table. For instance, in the tuning recommendations, it'll say this table, database needs a table. This table needs an index, or we need some query optimization that might be might improve things in here. Same thing with the query performance insight. And last but not least, if all of this seems completely new to me, I can actually turn on automatic tuning. But see, by default it is inheriting from the server, which I believe is turned off. It doesn't say. I can go ahead and say don't inherit and go ahead and turn on forcing of plans, creating of indexes, and dropping of indexes. Yeah, current state is off. So I can go ahead and turn those on, and so as the SQL server is going along, it will create and drop indexes as it sees fit. If it sees a certain area that needs an index, it will create one. If it sees an area that doesn't need an index, it will drop it. It will also change how the plans work depending on how it's seeing the environment working. If one plan is promoted by the application, but the database sees that a different plan improves the performance, it will force that instead. Do you necessarily know what all this means? Maybe not. Do you need to know what all this means? Maybe not. You're not a SQL person, you're an Azure person. You're simply turning it on in order to improve performance for your company until they can hire a full-blown SQL DBA. Along with that, well, hey, there's alerting for the performance. There's metrics for the performance. We can have it go ahead and look for just basic CPU, memory, latency kind of issues, and alert me whenever some of those metrics are exceeded. Automatic tuning, scaling up and scaling down. Well, if we can scale up, scale down for our web servers, of course we can scale up and scale down for our SQL. This is where things get a little interesting. This right here, this is my server, is ECG SQL 001, and then my database is widget creator. The scaling up and down needs to happen on the server, not on the database. So, that being said, I need to go to the server, right here. And I should be able to change the size over here on the left-hand side. Somewhere. Should be able to change the size in here. Is it DTU quota? No. Alright, I'm looking for it. Quick start. No. Alright, it's in here somewhere. I can change the size of the machine. I'm not seeing it right off the bat. But I should be able to change the size of the machine. I should be able to scale it up to a more higher performance system or scale it down to a less expensive system. Alright. Another really cool feature of SQL on Azure is automatic data classification and masking. So when I put a database in here, I can, under the security tools, tell it, go ahead and look at the database. Look at the data that's on the database and tell me what's in there. Tell me if there's anything I need to worry about. That is under the advanced data security. Let's see if this allows me to turn it on in the free version. What this will do is this will look through the data and it will discover it. Does this look like a credit card number? Does this look like a social security number or an address or a phone number or some other privacy related information? It will then help me automatically classify that so that I can then manage it appropriately. Once I've gone ahead and done that, I can do what's called masking. So I can go ahead and configure a database. Let's actually see if I can do this. If I can log in with my own personal account here. I actually have a database that does this for me. So you can configure a database masking so that when it finds, go away. When it finds data that you call questionable, you can mask it out and only show certain aspects of it. For instance, right here, I have a database, users 2 with a social security number. And so it sees, that's really boring. What it does is it sees a social security number. It sees a social security number such as 535121234 and masks it out to exactly what you're seeing there. So instead of seeing 535121234, you see XXX-XX-1234. What that means is that my end users, when they query this database, they don't see this. They see this. Do my end users necessarily need to see the full social security number? No. Most places you go to, they ask you for the last 4. And that's all you really need. It shows you the other X's to show that, hey, there is something else here, but you only see the last 4. Same thing with social security number, or not social security, credit card numbers. They normally ask you if you're talking to somebody online or on the phone, they say, are the last 4 of your credit card 1, 2, 3, 4? And if the answer is yes, then I'm pretty sure I've got your credit card number appropriate. This is really cool because you can then automatically publish this to the internet. Let's see, where's my... And I actually have a web service here. See if I can get to it. First time this has been powered on for several weeks, so it will take a few seconds the first time. But basically what that means is because it's being masked at the database, that information is not being sent across the wire. Somebody cannot sniff it and listen to what's happening on the traffic. Basically the traffic, as soon as it's left the database, is encrypted, and so when the end user gets it, the application doesn't need to encrypt it. It just simply shows the social security number of a bunch of X's and the number 8350. Now I can actually edit this. Let's see, this is Porter, Oregon, and I can go ahead and change his social security number 123-45-6789. I'm updating the social for him. I click save. Oh, and it errors out on me. Okay, I was gonna say you'll save it, but then when you come back to view it, it will be masked out again automatically. So that's the benefit of the dynamic classification and data masking. It identifies it, it classifies it, and then you can add in a mask so the end users don't ever actually see what the customer's phone numbers are, what their emails are, or what their credit card numbers are. They just see a masked version of it. All right, so all those benefits of using Azure SQL. You can still run SQL Server on an Azure virtual machine. You can build out an Azure virtual machine. You can manually install SQL on it. You can go through all that nightmare that I talked about previously about scoping out exactly how many drives you need and how big they need to be and what your performance characteristics are. But you can do it, which is a really good way if you're trying to transfer from physical to Azure and you're getting some pushback. So you can go ahead and you can do that. You can go move them in. There's basic suggestions. Use an A2 VM or higher. A2 really is the lowest end you would ever possibly want to use for SQL, so you're probably going to be looking significantly higher than that. Part of the obvious role here, put your storage account and the VM in the same region. Completely obvious. Keep your disks next to your server. If using multiple data disks to store data and log files, disable. Ooh, it doesn't say it. Disable. Georeplication. There you go. Disable georeplication. So you can georeplicate your VM from one location to another. This is saying go ahead and disable georeplication because what you save to your data disk may be slightly out of time with your log files, and georeplication will break that. Yeah, so when you recover in another location, your log files may be 5 minutes slower than your data files, or vice versa. Additionally, use the cache policy of set to none, so you can set your hard drives in Azure a reading cache, a write cache, or no cache. Set it to none. This is actually a good practice for all SQL environments. SQL caches the data automatically for you, so you don't need it to be cached otherwise. Part of the obvious, don't store anything on the D drive. The D drive is a temporary drive and is deleted automatically. You can put your temp DB on there, however. In in Azure SQL, There are some requirements such as having a clustered index. Idled connections are dropped after 30 minutes. You can only use port 1433, and all these requirements mean it is not supported by all applications. If you have a database that does not use a clustered index, needs idle connections to last for more than 30 minutes or less than 30 minutes, and does not use port 1433, you may want to go back and use an Azure VM and install SQL manually. All right, with that being said, Microsoft SQL, MS SQL is not the only option. Yeah, you can use MySQL in there. MySQL, it's an open source solution that's used by a lot of applications, specifically under Linux. Not only can you use MySQL, you can also use PostgreSQL. I believe that's how you say it, PostgreSQL, however you want to call it. There are some open source solutions that you can use in Azure as well. If you've taken the database class here at Green River, you're familiar with MySQL. Basically the same thing. You set up a pricing tier and you build out a server. Along with MySQL and PostgreSQL, there are other what's called NoSQL options. The first one is table storage. We talked about this when we were talking about file storage. Table storage is a JSON NoSQL type data store that works very quickly and very largely. The other option is what's called Cosmos DB, and this is a planetary scale database. You can literally have people throughout the entire world accessing the database at exactly the same time. So you get somebody in the US, somebody in Europe, and somebody in Asia, and they are all accessing the same database. If somebody in the US submits something, everybody from Asia and Europe can see it automatically. It is literally a planetary scale database. Yeah. Lots of information about its consistency. Multiple API support, so this can actually work as if it's a SQL database. It can work as if it's a Mongo database. There's several different database types that it can operate as. I don't know them off the top of my head. I've used SQL. This is really awesome. There's actually a lab on Microsoft Learn that you can do where you use a Cosmos database as a SQL environment. Feel free to take a look at it. So there you go. That is SQL on Azure. There's lots of great and amazing features there. Really, the point of it comes down to this is better than what I might be able to create on my own. It's better. It's a pay per second environment. So I don't necessarily have to pay for something I'm not using yet today, and yet it still works almost 100% the way I expect it to work locally.